All right, guys, so a little video here on ellipses and some of the important vocabulary and distances we need to know about them. We've probably done some kind of activity to help us either get the definition or understand what's going on there. And throughout this, we probably will do more, but definitely check out something to kind of show you a definition or how ellipses are created before you get into this. And I'm just going to jump right into our ellipse here and important distances, points, names, other things we have here. So there are some things that are similar to what we have in a parabola. For example, the center here, we don't have a vertex per se anymore, is going to be right in the middle of our ellipse. So this is going to be our center, and we label that HK, just like we do for the vertex of a parabola. Now there are vertices on an ellipse, and they are at the end of what we call the major axis. So just to avoid things getting too, busy here, I'm gonna actually write some important definitions down there. So the first thing we're gonna have is the major axis. And this is gonna be the segment or the line. It's kind of gray area depending on who you talk to, but I'm gonna say the segment that contains the center. And we're gonna get to some more things that's also on it, and that has endpoints on the ellipse. And its endpoints are the vertices. So on our ellipse, we call this guy a vertex and this guy a vertex. So the major axis would be this red dotted line I'm drawing through the center, going to each vertex. Now, another thing that is on the major axis are these two foci, or each focus. And hopefully through our definition, we saw why these are important, but almost if you cut in half our ellipse, here we go, kind of looks like a parabola, right, with the focus in the middle. Now they're not found the exact same way, but kind of good to note that focus is there. All right, another segment that we'll have, again, or line, depending on who you're talking to, is the minor axis. Now this also goes through the center, but it's perpendicular, so that's our perpendicular symbol, to the major axis. And I'm going to say goes through the center. There are a lot of different ways to define these. Another way we could define it is it has endpoints that are what we call our covertices. So this guy up top would be a covertex. It's not on the major axis, it's on the minor axis, which is the smaller axis. That's why it's called minor. And this would be our other covertex. So the major axis is always the bigger axis. That's how you'll tell which one is the major one. And the minor axis is always the smaller axis. So in the picture, we have the vertices. They're the endpoints of the major axis, and the covertices, which are the endpoints of the minor axis. So now I'm going to put three important lengths into this picture here. And the first is going to be the value that we call A. Adjust my screen a little bit here. And I'll also write what these distances are down here. So A is going to be half of the major axis, or the distance from the center to the vertex. From that, you could probably guess what B is. B is going to be half of the minor axis. Or the distance from the center to a covertex. And C is the distance from the center to a focus. Now, there is kind of a cool relationship between A, B, and C, and I'm actually going to draw it in this ellipse down here on the bottom right. So B, we said, would be center to covertex, so I'm drawing that in. C is center to focus, and we can make a right triangle with these. So if I draw on the hypotenuse, that's actually an important distance that we already have. That's A. So the relationship between A, B, and C, it's a Pythagorean relationship, but notice A is our hypotenuse. So our relationship is A squared equals B squared plus C squared. Now I'm going to write that up here again. A squared equals B squared plus C squared. That is probably the most important relationship that we'll have in our ellipse. Now, I do want to talk a little bit about why over here. I'm going to use this other ellipse for it. If you did the activity that I've done in class, or if you saw that GeoGebra applet up top, if you haven't yet, maybe pause this video and go check it out. The definition of an ellipse, we can demonstrate with a string. So no matter where I put a string on here, let's say I stretch a string, it's connected to each focus, and I've stretched it out to like this point. Anywhere on the circle. So if I drag this string somewhere over like here, let's say, right? That string has the same length. Even if I put it up here, all of these would be the same length. So for our definition of ellipse, we usually say it's a set of points where the sum of the distances from two fixed points is constant. So this segment plus this segment, wherever we are, if I add those up anywhere, that distance will always be the same. Obviously, if I move the string right here, right, these distances aren't the same, but the sum of those two segments, like if I had a string attached, right, that would always be the same. So let me get rid of all this. Don't have my keyboard up, so I can't just erase real quick, but that's pretty good. All right, so think about our string. And let's say I have a string and I put all the way over here to this end and back. So imagine it's laying on top of each other, but to demonstrate this, I don't want to really draw that in there. So a couple important distances. Here's our center here. So from center to focus, that's C. From center to focus, again, that's C. So like this distance would be C. This distance would be C. So far on our string, we've got 2C. And then over here, this part of our string would be, remember, the whole distance from center to vertex is A. So this little part of the string over here would be A, but I took away one C value. So this is A minus C. And also this guy's the same as that. So A minus C. So this string, if I add it up, is going to be equal to 2C plus A minus C, which was this guy, plus A minus C, which equals, my C's are going to cancel. Oh, no, I'll have a, yeah, 2C minus C minus C. So the C's are all going to cancel. The length of the string would be 2A. So kind of a roundabout way to demonstrate what we had over here. But think about if I stretch the string right to the bottom, directly to a covertex, we would have 2A would be the length of the string. So kind of a way to demonstrate that, a little roundabout, but that's the way to go. All right, so just some intro to vocab ellipses. You guys can check out the next video for standard form of an ellipse and 2 examples for graphing.